Why do sodium and chloride, two extremely toxic and harmful chemicals, combine to form normal table salt?
This is the beauty of chemistry. So you think that a thing's properties are somehow inherent in the thing, but the property is what manifests after you combine it with whatever else. So you combine sodium, which is a lethal metal that you can cut with a knife. That's how soft it is. And it reacts violently with water. Add that to chlorine, which would poison you if you breathed it. Put them together and you get completely necessary table salt, necessary for the life. So when you put them together, all the chemistry, it's a new chemistry. It's a new thing. Don't think of it as it probably has some of those properties it used to have. No, all that matters is what are its electrons doing when they talk to your electrons. And if the configuration is different, that's all that matters.
Way back in the 70s, he showed that black holes radiate. So although they're things that we think of as prisons, where it's anything that goes in can't get out, over a long time they evaporate away. So that was his great contribution, so-called Hawking radiation. And that raised a question that he asked first, which is, what happens then to the stuff that falls in over its lifetime? When the black hole has gone, is there any trace of that stuff left in the radiation, in the universe, when the black hole is evaporated? And that's a profound question because
So where did the information go, I guess?
Exactly. His calculation initially suggested that there was, and he stood by that for many years because his calculation, no one could find a problem with it, but his calculation specifically said that black holes destroy information, which attacks the foundation of physics.
Of everything.
It's determinism. It's
so
the idea.
So the eternality of matter itself, he called into question. And so I'm going to ask you two, was he right?
No, it turns out he wasn't right, and he accepted that in the end, actually. And in the last couple of years, there's been a great insight into why it is that his original calculation was wrong, and it's extremely subtle, very interesting. What we've discovered, which is just fascinating, is that by trying to understand the simple question that Stephen raised, we're being forced to confront the idea that space and time are not fundamental, that they emerge from some deeper theory. And no one expected that when we started thinking about black holes.